Hello everyone, my name is Rafael. I'm an electrical engineer, and in this video I'm going to present to you the solution of 4 exercises related to vector analysis. The present video is an appendix to the one by means of which the theory was covered. The link to the theory video is in the description below. Let's begin with the exercises. Given the vectors m and n, where m is negative 10ax plus 4ay minus 8az, and n 8ax plus 7ay minus 2az, find the letter A unit vector in the direction of negative m plus 2n, and letter B, the magnitude of 5ax plus n minus 3m. Okay, my friends, this is question number 1. Let's go to the solution. Firstly, let's call negative m plus 2n r. Okay? What we want to find? We want to find a unit vector in the direction of r, which is negative m plus 2n. How do we find a unit vector in the direction of a vector? Let's call AR the unit vector in the direction of R. And how do we compute AR? Simply dividing R by its own magnitude. Okay? That's it. Firstly, we find R. R is negative m plus 2n. This is the first step in calculating what the problem wants us to do. So R is equal to negative m, okay? We invert the sign of this, negative 10ax plus 4ay minus 8az, and we multiply n by 2 and sum n plus 2 times n, 8ax plus 7ay minus 2az. Okay? Now we simply do it. This negative here causes this to be positive, causes here to be negative, and here to be positive. And this 2 here causes here to be 16, here to be 14, and here to be negative 4. And when we carry out the operation, we find that it is 26ax plus 10ay plus 4az. Okay, this is vector r, which represents minus m plus 2n. And now what we do is simply compute the magnitude. We compute now the magnitude of r. The magnitude of r is going to be 26 squared plus 10 squared plus 4 squared and the square root of it all. Okay, the magnitude of a vector is the square root of the square of its component. And now we are going to, I'm going to leave it for you in your house, okay? It is extremely simple. I'm gonna let you do it. And now simply the unit vector AR in the direction of R is found by dividing the very vector by its magnitude. And this is equal to 0.92 AX plus 0.36 AY plus 0.14 AZ. Alright? You simply take this and divide by the number that you find here. I'm gonna let you calculate this. You're gonna find a number, you use the number here, and then you're gonna find this unit vector, and this is the solution of letter A. Letter B now. Easy. The magnitude of 5ax plus n minus 3m. Let's call it S. Vector S is 5ax plus n minus 3m. How do we calculate the magnitude? Simply, the magnitude, we have to firstly carry out this operation, and secondly, find the magnitude of what we find. Alright? Let's do it. Let's find S. S is gonna be 5 times AX plus N. Where is N? N is simply this. Okay, 8 AX plus 7 AY minus 2AZ and minus 3AM minus 3M. M is negative 10 AX plus 4 AY minus 8 AZ. After doing this, we find that it is 43 AX minus 5 AY plus 22 AZ. Now that we know vector S, which represents 5ax plus n minus 3m, we can calculate its magnitude. The magnitude of S is simply the square root of 43 squared plus negative 5 squared plus 22 squared, and this is equal to 48.6. Okay, this is the magnitude of the vector, and it is all for exercise 1. Let's go to exercise 2 now. Exercise number 2 now. Given points A and B, letter A, find the distance from A to B. And letter B, a unit vector directed from A towards B. Okay, my friends, this is the question, a rather simple one. Let's go, let's solve it. Letter A, the distance from A to B. The distance from A to B can be calculated by placing a vector from the origin to point A and placing a vector from the origin to point B and computing the difference in such a manner. The vector from the origin to point B minus the vector from the origin to point A, and vector B, we simply take the coordinates negative 2ax plus 3ay plus 2az, and we subtract from we subtract vector A from this minus vector A is 8ax minus 5ay plus 4az, and this results in a vector such as negative 10ax plus 8ay minus 2az. Okay? The exercise wants us to calculate the magnitude of the vector, which can be understood as the distance from A to B. And then we find simply that the magnitude will be equal to the square root of negative 10 squared plus 16 squared plus negative 10 squared, and this is equal to 12.96. Okay? 12.96. Letter B now, a unit vector in the direction from A to B. How do we find a unit vector in the direction of this vector here from A to B? We simply divide the very vector by its magnitude. So the unit vector from A to B is equal to vector B minus vector A divided by B minus A, the magnitude of this vector. We calculated the magnitude B, 12.96, then it is going to simply be 1 over 12.96 negative 10 ax plus 8 ay minus 2az, and this gives a vector such as the unit vector in the direction of this vector here is plus 0.62 ay minus 0.15 az. Okay, this is the unit vector in the direction of AB, pointing from B to A. Okay? No, from A to B. Okay? From A to B. And this is all for exercise 2. Let's go to exercise 3 now. Exercise number 3 now. Use the definition of the dot product to find the interior angles at A and B of the triangle defined by the 3 points A, B, and C. Okay? This is a question. Let's go to the solution. Firstly, you're going to plot the triangle to have a visual understanding of the problem. This is what I did here. Okay? The problem didn't give the triangle. The problem simply gave the points. But for a better understanding of the problem, I decided to plot the triangle so we can see what we're doing. Okay? And the problem wants us to find these angles theta and phi using the definition of the dot product. So let's go. Let's find first this angle here, angle phi. To find phi, we will use the definition of the dot product, R AB RAB is the vector, okay, pointing in this direction here, okay, from A to B. And a dot product with RAC. RAC is the vector in this direction here, pointing from A to C. And in accordance with the definition of the dot product between these two vectors will be the magnitude of RAB times the magnitude of RAC times the cosine of the angle between them. Okay? And what is the angle between them? RAB, RAC. The angle between them is phi times the cosine of phi. To calculate, we need to find the vectors, okay? RAB can be understood as the subtraction from the vector OB from the origin, this is the origin, from the origin to B, there will be a vector minus vector OA from the origin to A. Vector OB positions the point there. It goes from the origin to the point. Vector OA also positions the point from the origin to the point. Vector RAB is obtained from the subtraction of this minus this, okay? And it produces this vector here. Which is -3, 1, and 7. Similarly, we use what we saw there for vector RAC. Which can be obtained from the subtraction OC minus OA. And this is -1, -5, and 3. Alright, we are almost there. And we need the magnitudes. How do we calculate the magnitudes? Simply, the magnitude of RAB is equal to -3 squared plus 1 squared plus 7 squared, the square root of it, and we find the square root of 59. Likewise, the magnitude of R AC will be equal to the square root of -1 squared plus -5 squared plus 3 squared, and this is equal to the square root of 35. Consequently, R AB in a dot product with R AC will be equal to, we put this in Cartesian coordinates, -3ax plus ay plus 7az in a dot product with -ax minus 5ay plus 3az, and you know that the result of a dot product is a number, okay? We saw this in our theory video. Both the dot and the cross products are products. They are multiplications. The difference is that the result of a dot product is a number, while the result of the cross product is a vector. And if we compute this, we find 19. we have everything now. We are going to use this expression here in the place of this term here. We put 19. We are going to substitute this and this by this and this, okay? It is the square root of 59 times the square root of 35 times the cosine of the angle we seek to find. And we simply pass this dividing, and we find that the cosine of the angle is 0.9138. But we don't want the cosine, we want the angle. How do we find the angle from the cosine of the angle? We use the inverse cosine. The angle is therefore equal to the inverse cosine of 0.9138. And this produces an angle equal to 65.3 degrees, okay? And this is all for the day, okay? We are going to calculate for letter B in a similar manner. Let me erase this. Letter B now. Find this angle here, angle theta. We're going to use that RBA in a in a dot product. Sorry, the exercise wanted us to use the definition of the dot product. So, we are going to use the definition of the dot product to calculate theta, and we are going to use that RBA in a dot product with RBC is equal to the magnitude of RBA times the magnitude of RBC times the cosine of the angle between them, okay? And this angle is theta. RBA points from B to A. RBC points from B to C. And the angle between these two vectors is theta, alright? As we did before, RBA can be understood as the vector from the origin to A minus the vector from the origin to B. And if we compute, we find 3, -1, and -7. Likewise, R, B, C can be understood as the vector from the origin to C minus the vector from the origin to B. And if we compute, we find 2, -6, -4. Following a similar procedure, we shall now calculate the magnitudes of the vectors, the magnitude of RBA and the magnitude of RBC. The magnitude of RBA is equal to the square root of 3 squared plus -1 squared plus -7 squared, and this is equal to 59 and the magnitude of RBC is equal to the square root of 2 squared plus -6 squared plus -4 squared, and this is equal to the square root of 56. Next, we carry out this dot product here using Cartesian coordinates. R, BA, in a dot product with RBC is simply 3ax minus ay minus 7az dot 2ax minus 6ay minus 4az. Okay? We compute this dot product. Remember that the dot product between ax and ax is 1, ay with ay is 1, and az with az is 1. However, ax with ay and ax with az, ay with ax, ay with az, and az with ax and az with ay is 0. Okay? Remembering this, we find the 40 we have everything now. Using this expression here, in the place of this term here, we use 40. The product between the magnitudes, 59, the square root of 59 times the square root of 56 times the cosine of theta the cosine of theta, if we pass this dividing, the cosine of theta is 0.696, but we don't want the cosine. We want the angle. To find the angle, having the cosine, we compute the inverse cosine. As a result, our angle is 45.9 degrees. Okay, my friends? Beautiful, isn't it? And this is all for exercise 3. Let's go to the last. Let's go to exercise 4. The last exercise, exercise number 4. The 4 vertices of a regular tetrahedron are located at the points the origin, point A, point B, and C. Letter A, find the unit vector perpendicular to face ABC, pointing outwards. And letter B, find the area of the face ABC. Okay, the exercise didn't provide the image. For better understanding, I decided to draw the regular tetrahedron in accordance with the coordinates of the vertices. Okay, so let's go, let's solve it. The exercise wants us to find a unit vector perpendicular to face ABC pointing outwards. Face ABC is this, here is C, below it B, and to the right A. Okay? And the unit vector points outwards, like this. AN is the unit vector perpendicular to the face, pointing outwards. The unit vector will be in the direction of, we are going to use the cross product now. You remember that the cross product produces a unit vector and a vector normal or perpendicular to the plane containing the other two vectors. Okay, so let's suppose there is a vector here. Okay, let's review the theory. Imagine here the xy plane. Okay, x is here, x belongs to the plane, y belongs to the plane 2. Okay, if we use the cross product between them, it is going to produce vector z. But vector z is not in the plane, it is above the plane. Okay, for example, imagine that the x direction is here and the y direction is there. Okay, they make a plane. They are part of the plane. If we use the cross product, we produce a vector pointing outwards in the upwards direction or in the downwards direction. Okay, this is what the cross product does, and we are going to use the cross product to find this unit vector pointing outwards from face ABC. Okay? Knowing that, we have everything to find what the exercise wants us to find. Okay, R, B, A, in a cross product with R, B, C. Okay? And RBA, as we did before, RBA can be understood, RBA can be understood as OA minus OB. Likewise, RBC can be understood as OC minus OB. We're going to use this to calculate, okay? I am going to let you try simply locate vector OA from the origin to A, locate vector OB from the origin to B, and you're going to find a vector, and this vector is RBA. Similarly, locate RBC as OC minus OB, and use the coordinates of C in the coordinates of B and the origin. OC is going to be from the origin to C and OB from the origin to B. And in this way you find RBC. Alright? And if you carry out the cross product using Cartesian coordinates or Cartesian unit vectors AX, AY, and AZ, you're going to find that RBA in a cross product with RBC is 0.41 AX plus 0.71 AY plus 0.29 AZ. Okay? Remember that AX in a cross product with AX is 0. Okay? Because the sign between them is 0 degrees and the sign of 0 degrees is 0. Similarly, AY in a cross product with AY and AZ in a cross product with AZ also produce 0. Okay? However, AX in a cross product with AY and AY in a cross product with AX, AY in a cross product with AZ, and AZ in a cross product with AY, and so on, will produce another unit vector. Okay? Remembering this, we find this here. Okay? And to calculate the unit vector in the direction of this vector here, okay, to calculate this, which is in the direction of this, we simply divide this very vector by the magnitude of the vector. Okay? It is going to be AN is going to be the cross product divided by the magnitude of the vector resulting from the cross product. And how about the magnitude? I'm gonna let you try. And I am going to simply tell you that the magnitude is 0.869, and the vector is, as aforementioned, 0.41ax plus 0.71ay plus 0.29az. And if we multiply 1 by the magnitude with the vector, we find that an is equal to 0.47ax plus 0.82ay plus 0.33az. Okay? This is the unit vector in the direction of this vector here. To finish, we go to letter B and we calculate the area of the face ABC. How do we do it? We can use the cross product in such a way. The area of the face is going to be a half of the product, much like what we do in geometry to calculate the area of the triangle. RAB cross RBC, and we want the magnitude only, and this is simply this, the magnitude, divided by 2. 0.43. And this is all for the video, my friends. I hope you enjoyed it and learned from it. I am a teacher. If you want to book a lesson with me, use my WhatsApp number, guys. Goodbye.